Hello and welcome back. We have understood what is k-means clustering algorithm. Now we will try to understand how exactly the algorithm works and how to choose k. Because as a data scientist, we need to choose the best k. Right? How many clusters a data set should be split into should be decided by us. How do we decide? By looking at within cluster sum of squares, a measure called as within cluster sum of squares. It is also called as inertia underscore in scikit-learn. So what is within cluster sum of square? The main objective of k-means clustering algorithm is to find out a cluster. A good cluster is one for which the within cluster variation is as small as possible. It means this is the calculation. So if you take a data point within a cluster, but if a cluster has got 10 data points, you take distances between, you take the L2 norm of the data point and the centroid and do the square. L2 norm is going to be one number, right? L2 norm is what? Square root of x1 minus c1 square plus x2 minus c2 square plus and so on, xp minus cp square, when there are c and p number of the features are there in the data set. So the square root, right, if you square it, it will go off, so you will get one number. So between each data point and the centroid, you calculate the sum of all the distances, right? That should be minimal. Initially, when the centroid is randomly chosen, this is going to be high. When the algorithm calculates the mean of all the data points within a cluster and chooses that as the centroid and tries to calculate distances, reassign the the cluster numbers, right? The within cluster variation reduces, and at one point in time it stops reducing. That is the optimization objective. So if you have 3 clusters in your data set, or you decided to do 3 clusters of the data set, then each cluster minimizes, each cluster's variation minimizes. If you sum up all these 3 clusters variations, that's going to be minimal at one point in time. That's the point where the algorithm will stop learning, the iterating through. So mathematically speaking, the algorithm will stop iterating when the within cluster sum of squares of total all the clusters becomes minimal. So that is the optimization objective. If you have k number of clusters in your data set, and each cluster has got n number of data points, generally there will not be equal number of data points in all the clusters, but for formula purposes and understanding purposes we have kept n. Maybe cluster 1 will have n data points, cluster 2 will have m, cluster 3 will have maybe r number of data points. So all those data points with those centroids, right? First cluster, it's a centroid and the data points distances, the L2 norm, square of L2 norm, and second cluster, the data points and the distances L2 norm square, and third cluster and the L2 norm of all the data points with the centroid. Sum up all these 3. If that is minimal, that's when the algorithm stops learning, or algorithm stops calculating the mean of the data points inside the cluster and then tries to calculate distances of all the data points. That whole calculation will stop when within cluster sum of squares stops. It is like a society, right? Every home is good, the total society is good, right? Every home is a cluster, total society is a data point, right? So if every home is peaceful, the total society is going to be peaceful. So the algorithm tries to bring the homes to in such a way that the homes are peaceful, or the distances are lesser, like that it is. So we are trying to calculate the within cluster sum of squares by taking each cluster's variation. So that is how the algorithm works. Choosing number of clusters k is the toughest thing in k-means clustering. So what we do is, we actually start with 2 clusters, build a model, try to see what is the within cluster sum of squares, and 3 clusters, see what is within cluster sum of squares, 4 clusters, like that. You try to build maybe 5, 6, maybe 10 number of models with 2, 3, 4, 5, 6, like that, and wherever you get the within cluster sum of squares less, you choose that as the best k, right? Best k for the algorithm. Okay, so that is a tricky part, and this is one approach I explained. This is called as elbow curve approach. There is another approach called as silhouette score. We'll see that those two now. So choosing k is the toughest task. Once chosen, right, k-means algorithm will assign each observation to exactly one of the k clusters. That means k-means clustering will do non-overlapping clusters of the data, non-overlapping groups of the data. Okay, and then there is another parameter called as k-means plus plus in k-means clustering. When you say k-means plus plus is equal to true, or init is equal to k-means plus plus, the algorithm chooses the initial clusters intelligently. In k-means, what is happening? When I say 3 clusters, it chose randomly 3 data points, and then it started doing the distances between all the data points, and assigned all the closest data point to the cluster, then did the mean and moved the cluster centroid, like that it did, right? But instead of randomly choosing, if we can choose the centroids intelligently, the number of iterations will reduce. The k-means plus plus will do that. When I say init is equal to k-means plus plus in the scikit-learn, what it does is it chooses the first cluster centroid randomly, and chooses the second cluster centroid which is far from the first cluster centroid, so that the second cluster centroid is always on the other side or the other cluster. Okay, so if you have 3 clusters, right, it chooses first one randomly, second one calculated, farther one, third one which is far from these two, fourth one maybe far from all these 3, something like that. So the k-means plus plus is an initialization process, cluster centroid initialization process. It actually reduces number of iterations and in finding the best cluster centroids. So that is k-means plus plus. And k-means algorithm cannot work on huge volume of data because it does the calculations, right? The Euclidean distances it need to calculate. First thing is randomly choosing, next thing is calculating distance between the centroid and all the data points. If you have 1 million data points, right, it starts calculating distances. It is like KNN only. Even KNN also, while predicting, it will take lots of time. Like that here also, from the centroid it starts calculating distances between all 1 million data points, and then tries to assign closest data points. Again the second centroid calculates distances, third calculates distances. So here also we can use the algorithms like brute force, KD tree and ball tree. Okay, these are kind of optimized algorithms to calculate the distances fast and try to find the closest data points fast. So k-means algorithm is very bad at working with huge volumes of data. It will not work even with the ministry data set where we have 42,000 records. I tried to run the model and it took like maybe around 3-4 hours to finish the cluster finding, best cluster finding. So we'll see that in a moment. And mid-size data sets, it takes lots of time in finding. This is the example. Ministry data set is the example. If you don't believe me, I'll give you the data, the code, and you just try it out. Okay. So the next question is how to choose k. We'll see that in coming session. There are 2 approaches: elbow curve and silhouette score, silhouette analysis. So we'll see those 2 in the coming session. Thank you.